First step towards achieving your dreams is having the right coach. Get the best education with Maths by Nitin sir and make your government and academic exam dreams come true. Download the app now.
Look at this man running. He is training to run a marathon. He's covering a distance of 3 meters every second. So the distance he covers each second is constant at 3 meters and he maintains the pace for a certain period of time. This is what we describe as uniform motion. So in case of uniform motion, if we know the constant distance covered for each time period, along with the total time duration of motion, we can calculate the total distance covered. What do I mean by this? If I said this man ran at a uniform speed of 3 meters per second for a minute, can you tell me how much distance he covered? A minute is 60 seconds. Each second the runner covered 3 meters. So 60 times 3 is 180. Don't forget the units, the answer would be 180 meters. Similarly, we can calculate how much distance he will cover in 10 minutes, 20 minutes, or even an hour. That's because he's maintaining a constant speed. Uniform motion. Distance traveled by an object in unit time is called speed. It's distance per unit time. So what will be the units? Can you guess? The SI unit of speed is meters per second. Quite often you will also see speed denoted in centimeters per second, miles per hour or kilometers per hour, but the standard unit remains meters per second. We observe this gentleman here running at a constant speed of 3 meters per second. He is definitely a thorough professional, but in our day-to-day lives, it is very rare to see uniform motion, whether it is walking or running, riding a bicycle or being in a car. We walk briskly for a while and then get tired and our pace slows down. Most of the times, we are not even in control of the speed. There are external factors like traffic lights, busy crowded areas and the like. The bicycle ride is fast at times and slow at other times depending on which area of the school you're in. Same goes for driving a car. Such cases are examples of non-uniform motion. The speed of the object is not constant. So hang on, can we calculate speed for non-uniform motion? As the motion is not uniform, it will have different speeds at different points in time. When it comes to non-uniform motion, we refer to the rate of motion in terms of average speed. Yes, that's right, average speed. So how can we derive average speed? This boy leaves point A to reach point B, which is 60 meters away from A. And he has been walking at varied rates of motion, basically non-uniform motion. He takes 60 seconds to reach point B. So he has covered 60 meters in 60 seconds. What is his speed? Can you tell? You'd have probably guessed. We look at the total distance covered and divide it by the time taken to arrive upon the speed. So this boy has covered 60 meters in 60 seconds. So 60 divided by 60 equals 1 meter per second. That's his average speed over this distance. It is as simple as that. But you have to be careful with the units used. What you have to get into the habit right away and stick to standard units. If you understand it well right now, it will help avoid silly mistakes in the future. If I had said this boy has covered 60 meters in 1 minute, you should not make the mistake of writing 60 divided by 1 equals 60 and say he's traveling at a speed of 60 meters per second. That's as fast as a bike. The best way, normally, would be to convert to standard units. So let's convert 120 meters in a minute into meters per second. Meters is already in standard form. As the standard form of speed is meters per second, we need to convert this minute into seconds. 1 minute equals 60 seconds. This would mean distance covered was 120 meters in 60 seconds. So what was the distance covered in 1 second? Correct, 2 meters per second. So make sure to stick to standard units for now and always mention the units being used. Average speed is a good way to know when you will reach a certain destination in traffic. There will be times when you will be driving fast and other times you will be stuck. Hold on. At every instance, you are moving at some speed. It may be 0 meters per second when you're stuck, or 2 meters per second, or even 4 meters per second. Do you know what the speed at each instant is called? It is called instantaneous speed.